On example A, we have ourselves a trigonometric antiderivative that we're trying to find. When I'm looking at this, I can see a couple of things happening here. So first of all, I've got myself a product of functions. I've got composite functions like all over the place, like 3x is inside of both cosine and sine. And then remember, sine squared of 3x actually means this. It means sine of 3x, all of that squared, right? Okay. So there's a lot of things going on in this one. Which one is going to be your u? So you got lots of options. You got to decide. Is it going to be 3x? Because that's what, we might think that 3x, that's the interior function here. Maybe our u is equal to 3x. Let's give it a try. So then that means that a du is equal to 3 dx. Not really a problem because we can fix a 3. Just cram it in there, multiply by 1/3, and then I guess we should just rewrite our integral here. Oh, don't forget the 1/3. Oh, 1/3 integral. This 3 with the dx becomes the du. Yes. All right, and then all of the 3x's, all of our 3x's are going to become u's. So I still have a sine squared here. Sine squared of u, and then multiplied times a cosine of u. Now I have a problem. I have a problem because I still have a composite function. I have sine inside of the squaring function, and then I also have it being multiplied times cosine. So what we did is we chose the wrong thing for u. It may have been the obvious choice, but it was the wrong choice. Now, another one of the tips, of course, was that I'm going to kind of combine up two. What part of this is the more complicated part? And what part of it has its derivative also inside of the integral? So the answer to both of those questions is the sine part here. The sine squared of 3x. The sine squared of 3x is not going to be the u. Instead, it's just going to be the sine of 3x because the derivative of that is cosine of 3x times 3, which is part of this, right? Okay, so obviously this is more complicated than that because we're squaring it. That's the part that we're going to try next. So I'm going to rewrite this. Integral sine squared of 3x times the cosine of 3x and dx. Let's give sine of 3x a try, which in itself is a composite function, right? Yeah, don't worry about it. Take the derivative. Derivative of sine of 3x is cosine of 3x times the derivative of the interior function. That's going to be a 3. And dx. And then look at what we have here. Let's use a highlighter. We have cosine of 3x. We have cosine of 3x d. What happened to the x there? Fixed it. Speaking of fixing things, the next thing that we need to fix is the fact that there is no 3. 3, 1/3. Now let's try to rewrite this thing. So when we rewrite it, 1/3 that's on the outside is going to stick around. Integral of the 3 with the dx, actually the 3 with the cosine of 3x times dx, all of that together is du. Stop randomly moving my screen. Who am I talking to? Pretty much myself. It's my hand that moved it. All right, and then the sine squared of 3x, sine squared of 3, well, first of all, maybe I should think of this as, once again, sine of 3x, quantity squared. I am just using the u as the sine of 3x, and then I would have the little square on the outside of it. It just becomes u squared. There you go. Look how simple that became. Super complicated, not so complicated. All right, let's take its antiderivative. I've got 1/3 times u to the third divided by 3. I'll just multiply that by another third, and then plus c, 1/9. That looks like an A. 1/8, 1/9. What is our u? Sine cubed of 3x, and then plus c. If you ever have a bad feeling about it, you could always take the derivative, which is what I'm going to do to check this. Let's see, let's bring down the 1/9 and leapfrog the 3 down. So I'm going to have times 3 sine squared of 3x times the derivative. So I'm going to rewrite that again like this. The sine of 3x squared. So we took the derivative basically of the exterior with respect to the interior. Now we have to take the derivative of the interior. What's the derivative of sine of 3x? It's cosine of 3x. Oh, yeah, but I have another composite function, so I have to multiply times the derivative of 3x, which is times 3. And get ready to cancel, because this 3 together with that 3 makes 9, which cancels out with this 1, and then you can see what we have left over is exactly the integral that we started with. Yes. So this brings us to this thing called the general power rule for integration. Oh, whoops, went too far. If g is a differentiable function of x, then the antiderivative of g to the x, g of x raised to the nth power times g prime of x, so you can see that here's our interior function, and its derivative is part of the integral. So then you just treat this basically as just one big x to the nth. So what's the antiderivative of x to the n? It's n x to the n plus 1 over n plus 1. So you do the same thing here. It's g of x to the n plus 1, all of that divided by n plus 1 plus c. And of course, that assumes that n is not equal to -1, because if that was the case, then you've got yourself a natural log kind of function here. And so here it is rewritten in terms of u's instead of g to the x's. So essentially that's what we just did right over here. It's that we had our function was this sine x, sine of 3x that's raised to some sort of power there, that general power rule. So let's we can see that like if you recognize it, it's going to make these on example 8 very, very quick to solve. So notice that I have a composite function. This function here is raised to the 4th power. What would its derivative be? It would just be a 3, right? So already I can see that this is really just a u to the 4th power. So I take its antiderivative. That would be, I guess I'm writing in green now. I'm not going to change. I'm going to stick with green. Okay, it's going to be 3x minus 4 to the 5th power over 5 plus c. Go ahead, take its antiderivative, or take its derivative to check it. This 5 would cancel out with this 5. 3x minus 4 to the 4th power, multiply it times the 3, and then that's where that 3 comes from right here. All right, we can do that also on the second one over here. So notice the more complicated part, its derivative is right here. Here's a function raised to a power, and its derivative would be, I'll take the derivative of that. I get a 2x plus 1, which is, oh, it's right there. All right, so again, this is just basically a u to the 4th. So its antiderivative is going to look exactly like this. So it is also x squared plus x raised to the 5th power over 5 plus a c. All right, I got a couple of them for you to give a try too. Right here on example 9, it's the same process. I know they look a little bit scarier, but they're not. Go ahead and give it a try. Basically an application of that general power rule.